So today's lesson is going to be dealing with performing single function transformations on multiple parent functions. And tomorrow will be multiple transformations, but today we're going to start with just one transformation at a time. To begin, you have a warm-up. You have to solve the system. You can use graphing, substitution, or elimination because I did not specify. My preferred method is substitution, so that's what I'm going to do. I'm going to substitute what y equals and shove it in my equation. So I will have x squared plus 20x plus 80 plus 10 equals x. I'm going to subtract x. So I have x squared plus 19x plus 90 equals 0. Now when I factor x and x, multiples of 90 that add to 19 will be 9 and 10. That equals 0. Set both equal to 0. X plus 9 equals 0. X plus 10 equals 0. Solve. I get x equals negative 9. X equals negative 10. However, because we're solving a system, we are not done. We need to take our x's and find corresponding y's. I know that y plus 10 equals x. So y equals x minus 10. If I plug in negative 9, y equals negative 9 minus 10. So y equals negative 19. And if I plug in negative 10, y equals negative 10 minus 10. Y equals negative 20. So my two ordered pairs are negative 9, negative 19, and negative 10, negative 20. Final step is to check both answers in original equations. And if you do so, you will see that they both work. So right here is my final answer. For today, you are going to need a graphing calculator of some kind to work through the notes. And to begin, before we can do a transformation on a function, we first need to understand what the original function looks like. And these functions are called parent functions. This should be somewhat a review since we know all three graphs. But if we graph x squared, if we make a table to see values, if we have negative 2, y will be 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So these are standard points that we'll always have. So we have there, 2, 4. My graphs are not going to be perfect, but you'll be able to see what they look like. So, parabola centered at the origin, facing upwards. X cubed if we have x and y values. Negative 2, negative 8, negative 1, 0, 0, 1, 1, and 2, 8 are our standard points. So if we graph that, we have the origin, 1, 1, 2, 8, 2, 3, 4, 5, 6, yep. Negative 1, 2, negative 8. And if we graph this one, let's try that again. It's going to look like that. Notice it has that S shape to it through the origin. And finally, we have absolute value. Standard points, x, y, negative 2, 2. Negative 1, 1, 0, 0, 1, 1, 2, 2. Somewhat similar to a parabola, but not quite. So we have negative 2, 2, negative 1, 1. And if we connect our points, we have a V-shaped graph that is centered at the origin. These are our standard parent functions. On your assignment, you'll be asked to graph these and then regraph them once applying a transformation of some kind. So, how are we going to transform parent functions? And here is where I want you to be looking at it on a graphing calculator.